Coffee Break Collection 13, Weather. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Fog, from Meteorology or Weather Explained, by J. G. McPherson. To many, nothing is more troublesome than a dense fog in a large town. It paralyzes traffic, it is dangerous to pedestrians, it encourages theft, it chokes the asthmatic, and chills the weak-lunged. In the country it is disagreeable enough, but never so intensely raw and dense as in the city. On the sea, too, the fog is disagreeable and fraught with danger. The foghorn is heard in its deep, somber note from the lighthouse tower, when the strong artificial light is almost useless. But a peculiar sense of stagnation possesses the dweller of the large town when enveloped in a dense fog. Sometimes during the day, through a thinner portion, the sun will be dimly seen in copper hue, like the moon under an eclipse. The smoke-impregnated mass assumes a peculiar pea-soup color. Now, what is this fog? How is it formed? It has been ascertained that fogs are dependent upon dust for their formation. Without dust, there could be no fogs. There would be only dew on the grass and road. Instead of the dust-impregnated air that irritates the housekeeper, there would be the constant dripping of moisture on the walls, which would annoy her more. Ocular demonstration can testify to this. If two closed glass receivers be placed beside each other, the one containing ordinary air and the other filtered air, that is, air deprived of its dust by being driven through cotton wool, and if jets of steam be successively introduced into these, a strange effect is noticed. In the vessel containing common air, the steam will be seen rising into a dense cloud. Then a beautiful white foggy cloud will be formed, so dense that it cannot be seen through. But in the vessel containing the filtered air, the steam is not seen at all. There is not the slightest appearance of cloudiness. In the one case, where there was the ordinary atmospheric dust, fog at once appeared. In the other case, where there was no dust in suspension, the air remained clear and destitute of fog. Invisible dust, then, is necessary in the air for the formation of fogs. The reason of this is that a free surface must exist for the condensation of the vapor particles. The fine particles of dust in the air act as free surfaces on which the fog is formed. Where there is abundance of dust in the air and little water vapor present, there is an overproportion of dust particles, and the fog particles are, in consequence, closely packed, but light in form and small in size, and take the lighter appearance of fog. Accordingly, if the dust is increased in the air, there is a proportionate increase of fog. Every fog particle, then, has embosomed in it an invisible dust particle. But whence comes the dust? From many sources. It is organic and inorganic. So very fine is the inorganic dust in the atmosphere that if the 2,000th part of a grain of fine iron be heated and the dust be driven off and carried into a glass receiver of filtered air, the introduction of a jet of steam into that receiver would at once occasion an appreciable cloudiness. This is why fogs are so prevalent in large towns. Next, the minute brine particles, driven into the air as fog forms above the ocean surface, are the burnt sulfur particles emanating from the chimneys in towns. The brilliant flame, as well as the smoky flame, is a fog producer. If gas is burnt in filtered air, intense fog is produced when water vapor is introduced. Products of combustion from a clear fire and from a smoky one produce equal fogging. The fogs that densely fill our large towns are generally less bearable than those that veil the hills and overhang the rivers. It is the sulfur, however, from the consumed coals, which is the active producer of the fogs of a large town. The burnt sulfur condenses in the air to very fine particles, and the quantity of burnt sulfur is enormous. No less than 7.5 millions of tons of coals are consumed in London. Now the average amount of sulfur in English coal is 1.25%. That would give no less than 93,750 tons of sulfur burned every year in London fires. Now if we reckon that on an average twice the quantity of coals is consumed there on a winter day that is consumed on a summer day, no less than 347 tons of the products of combustion in extremely fine particles are driven into the superincumbent air of London every winter day. This is an enormous quantity, quite sufficient to account for the density of the fogs in that city. End of fog.